Pleasure to meet you all here. Thanks for attending. My name is Mo, founder and CEO of Lithios. We are a seed stage startup based in Cambridge, Massachusetts, developing technology for low-cost lithium production. So I was a chemical engineer, PhD student at MIT. I graduated 2 years ago and founded Lithios, to develop our technology, ALE, Advanced Lithium Extraction, to enhance the production of low-cost lithium for rechargeable batteries. Now, the lithium industry is rapidly growing, as you all know. Lithium is an abundantly used element in a number of industries, obviously being driven largely by growth in demand for batteries. And we see a significant projection for deficits in lithium supplies over the coming decades that will not be mitigated by simply relying on the status quo methods for lithium production, which presents a significant opportunity for new technologies to bridge this gap. So the way by which lithium is mined today includes the traditional open pit mining process from a mineral called spodumene. It's a highly capital intensive process that is quite polluting. Moreover, there is a second method called brine mining, which involves the use of passive solar evaporation in large surface ponds that extract lithium from aqueous brines, which are very salty water deposits, primarily found today actually in the Atacama Desert and elsewhere in South America. And today, there are a lot of technology startups developing what are called DLE technologies, or direct lithium extraction methods, basically pond-free ways of extracting lithium from brine, but these tend to require huge quantities of expensive and toxic reagents. They use a lot of fresh water and produce a lot of waste. Not to mention, they are unfit for low-grade brines, which typically have low levels of lithium and large quantities of contaminants. Lithios is developing ALE to selectively extract lithium from brine to produce a purified lithium concentrate, as well as a lithium poor brine that can then be re-injected and returned back to its native source. This method is fully electrified, uses no chemicals whatsoever, and it uses very little quantities of fresh water. Moreover, the method is very selective for lithium, allowing us to access the toughest untapped brines out there, in addition to using a very low footprint and enabling high yields of lithium. The method is an electrochemical platform that looks a lot like a battery from the inside. So we're zooming in, on a pair of layers in that electrochemical stack, whereby the lithium from a flowing brine is inserted into a lithium selective electrode in one step. And then in a secondary step, the lithium is released back into a recovery solution to produce that purified lithium concentrate. We can then take that concentrate and deliver it to a refiner, or simply carry out the refining ourselves to produce battery chemicals such as lithium carbonate or lithium hydroxide. And as I mentioned, both capture and release steps here are mediated by the use of electricity only and no other chemical reagents or solvents. So the focus so far has been on applications in brine extraction, but our technology platform is quite versatile and can be used to refine lithium from secondary sources, including those rock concentrates, as well as waste batteries, as a matter of fact, where typically there are leachates produced from dissolving these components in acid that Lithios could then take to refine the lithium. So today we have two, confidential pilot agreements that we're developing, one based in the US, one based in South America, and we're looking to expand our pipeline further to carry out pilot scale projects at a scale of 1 ton per annum of lithium production by 2025. We're focused on markets in the US and Latin America at the moment, hoping to expand into Europe and working with potential off-takers as well in Asia and globally. So with that, I'd be happy to take your questions. Thank you for attending.
Thank you, Mo. Great.
Pleasure.
So how would you say your technology compares to, expand a little more on how it compares to the state-of-the-art methods?
Absolutely. Yeah, thanks for that. So the leading method today that is being developed for lithium extraction by DLE is called ion exchange, which uses huge quantities of acid that often require the development of an acid plant on site. And typically you saw these projects can be in remote locations like the Atacama Desert, the high desert in Argentina as well, where it's very capital intensive and difficult to build such an acid plant and power transmission lines to power up that facility.
Thank you. Someone is asking, how does it work? But I think you've touched on it. You can expand a little more if you want on what Lithios is doing?
Certainly. So it's you could think of it as a flow electrochemical reactor, perhaps. The best analogy I can give you is could look like an electrolyzer, a fuel cell, where you flow in a lithium-bearing brine into that reactor. And then the surfaces of that system are coated with a lithium selective material that is storing the lithium in one step and then releasing it into fresh water in a secondary step. That fresh water then carries the lithium to a downstream refining process.
Okay, and what is your timeline right now to work with some lithium asset owners?
Definitely. So today we carry out test work basically in our lab at the benchtop scale with prospective partners. We then naturally tend to advance these conversations toward pilot discussions and pilot agreements, which we're looking to execute in 2025 and 2026, with the intent of working toward a full commercial project to produce a few thousand tons per annum of lithium product by 2028.